For this question, we're being shown an object with an unusual path downwards, and the object goes from A to B. So first off, we're going to try to determine what is the work done by the normal force. So since the normal force times the displacement is going to equal 0, since we know that the normal force goes in this direction and the displacement is in this direction, so it would be perpendicular to each other, this means that the work will equal 0, since we know that the normal force is ultimately perpendicular. So there is no work done by the normal force. And then for part B, we're being asked, what is the work done by F equals negative mg, and then the y direction? And this would be mainly the weight. So what is the work done by the weight? So since we know that mg is going downwards, the work would simply equal 0 plus mg times the displacement. And that would be the work done by F equals negative mg times the displacement, because that is exactly what we're being asked. And we know that the normal force is 0, and that's what's being added in this case. So then for part C, we're also being asked, what is the speed at point B? So to get to the speed, we have to know the net force, the net work. And then the net work would be the normal force plus the weight. And as we determined here, that's equal to 0 plus mg. We know that it's m times g, as we put down here, times the displacement again. So y1 minus y2, which is the displacement. And we also know that the net work is the change in kinetic energy throughout this travel. So to get to the velocity, which is what we're trying to find, the final velocity, since point B is at the end of the inclined plane, we would get mg times y1 equals half of m times the final velocity squared, and then the final velocity squared would give us 2g times y1, and then v2 would ultimately be the square root of 2g times y1. And if we had those values, we would just plug it in, and this would give us the final speed at point B.